Hello everyone, my name is Anthony Catania. This is my final video presentation for astronomy at Lakeland. I apologize ahead of time. I'm not very good at making videos of myself doing this, so it's going to be pretty much looking at me and my telescope the whole time. I'm going to be cheating, I'm going to be looking off notes. But I do have a couple things to show you. The reason why I'm doing my presentation on telescopes. The reason why I picked telescopes is because I have one and I'd like to show it to you guys. And also, you know, obviously with astronomy, telescopes are a pretty important tool. So, you know, I figured there's quite a bit of information out there to give. So anyways, during my little presentation here, my quick one here, we're going to talk about the invention of telescopes. We're going to talk about the different types of telescopes and what they're capable of. And then we're going to take my telescope here, I'm going to show you guys in a second, and I'm going to go through it and show you what it's capable of and how to use it. Okay? If you try to figure out who invented telescopes in the beginning, there's quite a few different names that come up. But the consensus is in 1608, the guy who had, a guy named Hans Lippershey in the Netherlands actually had an actual working telescope. So that's kind of what everybody kind of goes with. Now, Galileo's famous for astronomy, telescopes, and everything, because about a year after that, in 1609, he made some adjustments to Hans's telescopes, and he started looking at objects in the sky and in the universe. He made some great observations and discoveries, and that's kind of why he got famous, and that's why he's associated with it. And telescopes work by, they gather light, they collect light through a lens or a mirror. They can gather more light than we can see with our pupil, so it makes things more visible. If we look up into space, we can see stars and everything, but if you look through a telescope, that brings in more of the light that's out there that we can't actually see, and it allows us to see more objects. The light gathering power is associated with the size of the lens. So the bigger the lens, the more light it can bring in, the more objects we can see. Now, other than that, the other thing you got to worry about with telescopes is actually the resolution. So the resolution is also going to be determined by size. So the bigger the lens, the more you're going to be able to see, the more light you're going to be able to see. The bigger the telescope itself, then the better the resolution of what you're looking at. You'll be able to determine a little bit more details of what you're looking at. All right. So there's two different types of telescopes. There's refracting telescopes and reflecting telescopes. Refracting telescopes are the type that you think of, that's the type that Galileo used. The type you think of, you know, if you had a small telescope in your room when you were a kid. The long, skinny tubes. They have a lens at the end, and it focuses light down to the focal point at the end where an observer can look through and see the objects. Now the other type is a reflecting type of telescope, and what that does is instead of using a lens to focus light, they use a mirror to focus light, or mirrors. Okay. Actually, the type that I have here today is a reflecting telescope, and I'll be showing you. These are the little fatter, shorter ones that you see sometimes, and actually they're becoming more popular with the amateur astronomers and stuff like that. People are getting those in their homes now. They're a lot more clear than the refracting telescopes. They don't have the possibility of giving off as many false colors, stuff like that. There's just been a lot more technological advances. Actually, the refracting telescopes were invented by Isaac Newton back in the day. Now, one problem with telescopes that's actually becoming a growing problem is something called light pollution. Pretty easy to explain. If you live in a city or a densely populated area and you sit outside at night and look up, you're going to be able to see the Milky Way. Maybe sometimes you can see the Milky Way, but you can see Orion's Belt, you can see the Big Dipper, stuff like that, but you can't see the millions of stars that are out there. What's happening is anything getting off light, houses, street lights, buildings, stadiums, anything like that, all that light shines up at the sky, and that stops us from being able to see, everything that's up there. So what people do is if you go out to the country or on a mountaintop, there's not going to be as much light pollution up there, and you'll be able to see a lot more. Milky Way will be clear. You'll see thousands more stars. So this is what scientists are doing with their telescopes. They're trying to get away from light pollution. So some of the biggest telescopes in the world, like the GTS in the Canary Islands, it's got a diameter of 10.4 meters. That's in a very, very low populated area with very little light pollution. So they're able to see a lot more. Another thing that actually affects what you can see from a land-based telescope is the atmosphere itself. Visual rays and radio waves can make it through the atmosphere relatively easy, but something the infrared, X-rays, gamma rays, not so much. So in 1962, the United States and Britain worked together and actually put a telescope into space called Ariel 1. And since then, there's been many more. The Spitzer telescope, everybody's heard of the Hubble. There's another one called the Herschel Space Observatory. And these are different types of, they're looking at different types of wavelengths, pretty much, what you can see here. Gamma rays and X-rays are actually being used mostly to look at the hotter objects like stars. And then there's infrared as well to look at some of the other things, planets, celestial objects that are also out there. Now, as far as the land-based telescopes go, like I said, people have used traditionally the refracting telescopes, but the reflecting are becoming more common in households. Really, it just depends on prices. You can go get the old style telescope for pretty cheap for a smaller one. I mean, obviously there's expensive refracting telescopes, but the reflecting telescopes mostly are also going to go ahead and go up in price depending on what you want the capabilities to be. The one I have here, I'm going to show you right now actually. This here, sorry, excuse me, you can see it. No, I did not wear blue, so we match. Okay. Anyways, this is the Meade ETX 105 EC telescope. It's a reflecting telescope. Has a large mirror on the end there. If you can see, there's a couple other mirrors bouncing back and forth up into this optic site here. If you can't see, I'll show you a little better view real quick. On this side right here, this is a little monocular here to kind of give you a bearing if you want to look at the moon or something. It's got crosshairs in it, and you can center that, and then you should be pretty close for your main. Okay, there's a little computer on the end. Sorry. Comes with this little device here, little keypad, and I'll show you exactly what it does, okay? Hopefully that works out right. Sorry for moving you around. Alright, so you just flip it on. It runs off batteries or power cord. Fortunately, the guy where I got this from never got a power cord. But anyways, I'm going to work on that. Running off batteries right now, and then first thing it does, it pops up. It gives you a warning. It tells you, don't look at the sun. Okay, we're not going to look at the sun. Then you can go ahead and set what speed you want it to be at. Now, while you're setting this thing up on the stand, while you're setting this thing up on the stand, what you really have to do is make sure it's level, and then you point it north. Okay, it's pre-programmed for locations, so it's going to ask you some questions. Enter your date. We're going to say it's August 1st, 2017. Enter. We're going to say it's 8 p.m. because that's what showed up on there. Okay, daylight savings, yeah. And we're going to set it up for easy alignment because that's about all I know how to do so far. Anyways, so it tells you to put the telescope in the right position, facing north and everything like that. Okay, it's all done. Hit enter. Now, this part scared me at first when I first got it. It moves on its own. So what it's doing right now is it's slewing or moving towards the star called Vega. Okay, if you're facing north, it should kind of have a general idea of where that direction it is, and then it's going to go ahead and move the telescope horizontally and longitude, and it's going to get you in a general area, and it's going to make some fine adjustments at the end. So it takes a couple minutes, not really a couple minutes, about a minute, and then it'll go ahead and beep at you. And then once it beeps at you, what you have to do is you're supposed to look in here, okay, and you're going to make adjustments by hitting the arrows up, down, left, right. Once you find that star, you want it centered in on your optic right there, okay? So once you have that centered, you go ahead and hit enter. So now it's going to look for another star, all right? It's going to look for a star called Antares, okay? It's moving towards that. And then you're going to do the same thing. Once it beeps at you, it makes all its final adjustments and everything. You're going to look through there, make sure you have it centered in there, and then you're going to hit enter. Now, since you've done that, it has 2 points in space in a galaxy that are centered on telescopes. Now, using triangulation, they can determine where it is on the Earth, because you already entered the dates, the times, and everything like that, and they can tell where it's at. And now it will be able to tell where everything should be at this date at this time. All right, so it's just finishing up making adjustments for this star. So we center that in there, which we're not going to do because it's daytime right now and I'm inside my house. So, but anyways, we hit enter on that. So it's aligned. Okay, so now it gives you options. You can select looking for an object in space. Oops, this one. There it is. Gives you a glossary tour. Anyways, it can give you a tour of different things. It pretty much will go a couple of different places, things that you can see and tell you what it is. Or you can go ahead and pick what you want to look at. I'll pick an object, and then we can look in the solar system. We can look in, let's see, satellites. We can look at stars. We can look in the deep sky, constellations. All right, let's go ahead and just for easiness, let's look at the solar system. Hit enter. And you can pick through all the planets, moon, everything like that. So let's just say we want to look at Saturn. Okay, so we hit enter on Saturn. Tells you where it's at. Okay. Hello. Oh, I'm sorry. I'm hitting go to. You hit the go to button. Told you that's still there. And it makes adjustments and it goes to Saturn. Okay, it's gonna. So after it does its final focusing and you know final tiny, really small adjustments, it'll beep at you and tell you it's there. All right. Now, once that's done, you're gonna go ahead and look through your optic there and take a look at Saturn. Okay. You can make adjustments left, right, up, and down so you have it centered in there and take a look. Now this optics it comes with, there's many different ones you can use. These just kind of unscrew and come off. They come in different sizes. This is 26 millimeter. Here's one that's a 12.4 millimeter, and that's going to give you different magnification. The smaller the millimeters, the more magnification. So you can pick which one you want to look at. So you want to look at there. You just got to be careful because you can have too much magnification and you won't be able to see it very clearly. So you just kind of go with what looks best to you. Another thing that these come with are different filters. Okay, now the filters, which are in here, are pretty much, they do what they say. They filter light, different light colors. Okay, so this one is this is for lunar and planetary stuff. All right, this blue one here is actually the one that's most used for checking out the storm on Jupiter. And really what it does is they filter out certain colors. I mean, if we look at an object that looks great and everything, we could see everything, but if we filter out certain colors, we might be able to actually see more detail of that object. So you use these filters, and they are stackable, so you can filter out more than one object, and you can look at and see more detail of the object. There are so many accessories that you can get for telescopes like this. It really just depends on how far you want to take your hobby, how much money you want to spend. Um, but honestly, I think it's a good investment. It's, something that really isn't going to expire. Okay, if you're interested in it, then it's something that you'll always just have. So as long as you take care of it, obviously, and it's good that it gets other people interested. If you have kids, obviously kids will love it. But there's some people that go really crazy and spend a lot of money and are huge into this, and there's some people who just like me, just kind of do it for a hobby here and there. Bring it outside, let all the kids look at it and stuff, and see what they see. They're amazed when you show them a planet, or a really, really close up of the moon and see all the craters and all the details in there. They're absolutely amazed. They just can't get over it. That's been right there their whole lives and never really noticed it. So anyways, that's this telescope here. There's many different types of telescopes that you can get, all different types of price ranges. This one's working out great for me. I really do enjoy it. Anyways, that's pretty much my presentation. Hopefully it gives you a little bit of an idea of the basic knowledge of telescopes. I know it's not very, very detailed, but there's just so much out there that it'd be a little bit more than a 15-minute presentation. So that's a basic run through of what I got, and I hope you guys enjoyed it. And I'm sorry about all the ums and ahs and everything like that. Please go ahead and comment on it and let me know what you guys thought. Thank you.